These are all the doubts that you have sent me yesterday night.
Your screen, sir, not shared. Yeah, the highlighted part I didn't get from this.
Methods work because different substances travel at different levels of attraction to it. So these are different colorings, correct? So the dyes that are present, they are different. Now you see over here O and H, the G and H. Okay, both of them they are containing the same pigment because the RF value for both of them is same. Now here, if you are considering this S1, okay, now that is containing a different pigment because here the amount of attraction that is there for that pigment on that chromatography paper is different, so it is traveling different distance. That's why the method works, because different substances travel at different levels of attraction to it. So this is getting attracted to different level, that's why it is traveling only this much distance.
Okay.
Okay.
Yeah.
So that's the part of it. Anode made of titanium. That's okay. That is not important.
That I don't need to know.
No. That's useless. Unreacted ions Na plus H plus. Membrane due to difference in liquid pressure. See, basically this separation that is there. Okay, here anode cathode, why we are separating, so that automatically the gases that are evolved, they both get separated. And this is porous spot. Basically, initially when you are starting the reaction, okay, this brine that is concentrated sodium chloride, the concentrations will be equal in both the sides. But because here then there is these substances are formed, chlorine and hydrogen, there will be change in concentration of substances on either sides. Why? Because here these substances, of course, they are getting evolved, chlorine and hydrogen, and because here porous spot is there, so ions which are there, they can travel in wherever direction to balance the concentration. And you don't need to know from which substance is flowing from where to where. And here obviously you can see here chloride ions, Cl minus is decreasing because here chlorine gas is formed.
Yeah.
So in that way, to balance the concentration, the chloride ions will come in this direction. That's what is there.
Okay.
What's about this?
In this endothermic also there is activation energy of that much.
Endothermic, endothermic is this. The activation energy is this much. From wherever the reactant is there to start the reaction, this is the activation energy. यहाँ से यहाँ तक, from here to here. This is the activation energy. And then once the energy, so this is the energy that is required to break the bonds.
Okay.
And then energy required to release the bond will be from here to here. That is energy released when the products are formed, because this is bond formation.
Okay, so endothermic will have high activation energy.
And it will then release less amount of energy.
Okay.
Here it is releasing greater amount of energy, so the amount of energy in products is less even than that of reactants. Greater amount of energy is given out, that's why it is exothermic, and that amount of energy given out is in the form of heat energy. Therefore the surrounding temperature is increasing.
Okay. So like in an answer we had this point that the molecules have higher or the same energy as the activation energy.
No, that part is not important. Right now what is important is this, how much is absorbed and how much is given. Here amount of energy that is already it is possessing, this is reactants energy and this is products energy. The products energy is less than the reactants energy. It means some energy is given out to the surroundings. An energy barrier will always be there to start the reaction. Otherwise, if any reaction in which energy barrier is not there, then that type of reaction will be simply like this. Here there is no energy barrier in the reaction. What does this reaction state? That it does not require any energy barrier. Such type of reactions are called spontaneous reactions. Example, if phosphorus is exposed to air, usually phosphorus is stored under water so that it does not catch fire. Phosphorus ignition temperature is 30 degrees Celsius. It means if you expose phosphorus in air, if the temperature is 30 degrees Celsius, automatically without any activation energy it will catch fire, because that much energy is there in the atmosphere only.
For sodium also it is like that, right?
For sodium, no, that is oxidation. That is when you are exposing it to air, okay, because sodium is highly reactive. That's why immediately it will combine with oxygen that is present in the atmosphere. So for that also you can say that that reaction is spontaneous. It won't catch fire, of course, but then immediately you have seen in that video that immediately that surface gets tarnished. Immediately it starts reacting with oxygen as soon as it is exposed to atmosphere, and usually sodium is stored under kerosene. That is, more particles will have an energy greater than or equal to activation energy. Therefore, successful collision rate increases, resulting in the increased rate of reaction.
I didn't understand this point.
Actually, that point is not so much important. In fact, it will have energy equal to or greater than activation energy. What basically catalyst is providing is the surface area, the base at which, okay, basically what a catalyst will do, okay, here a surface is there, okay, this particle A will come over here, this is your catalyst C. Okay, it may be a metal surface or particles. Suppose this is your particle A, then particle B will come over here. Okay, this C, what it will do, okay, it will both combine together, and then what will happen, these A and B, once they have combined together, then it will send away. Then catalyst C remains unaffected. Same thing, then again this process is getting repeated. Basically what a catalyst does is it helps in reducing the activation energy, lowering down the activation. And see, suppose if this is a normal reaction that is occurring, okay, this is an exothermic reaction, because you see the energy of the products is less than that of reactants. If it is a catalyzed reaction, in that case what will happen, then the activation
will decrease.
The reaction will become like this. This is the reaction that is in which a catalyst is used.
Okay.
So the activation energy is reduced, therefore the rate of reaction is increased. The reaction becomes faster. Chromatography has proved very useful in analysis of biologically important molecules such as sugar. Okay, what is your question over here?
1 second. So this like amino acid can be seen in paper chromatography is viewed under ultraviolet light.
Because all chromatograms that are obtained, they may not be visible under normal light, visible light. Ultraviolet sun, the amino acids which are there, they may be sensitive to ultraviolet light. So if you put incident ultraviolet light on it, then they will be visible. That's why we are using ultraviolet light.
So this amino acid will break down or what?
No, obviously amino acid is broken down from protein only. But when you are doing chromatography, there is no chemical reaction. They are just getting separated. It's just a physical process.
Okay.
What is
From
this?
this
Hmm.
from this cracking thing, sir, it is compulsory that the this decane will form octane and ethane.
Not necessary. It can be any other combination also.
But there has to be something specific to produce the this thing, right?
No, that you don't have to basically learn. Okay, it depends upon condition, what pressure, what temperature, what catalyst. Even mixtures also will be formed in this case, which you can separate them out by fractional distillation. So
Okay.
here C10 is there, which is getting separated into C8 and C2. It can be C5, C5 also. C5H10,
Mm.
C5H12. It can
Okay.
be C4, C6 also. That way separation also can take place. It's not necessary that it has to be like this only.
Okay. So what is catalytic cracking?
The cracking which is done in presence of catalyst.
Okay.
Catalyst is used in that cracking process.
From this one.
This one,
This chloroethane. Can you draw the structure?
chloro,
Chloroethane.
chloroethene.
Sorry, ethene.
It's not ethane.
Will
Okay.
it be CH3Cl?
How it can be CH3? It is ethene. Eth means two.
C
Correct.
C2H4.
Ethene means double bond is there.
Hmm.
Okay. This H, and one
Hmm.
chloro is there. So Cl will come over here.
That double bond will not break.
Double bond. That is when it is going to become PVC, polyvinyl chloride. When it is going to get repeated.
Or when we add steam to it, then it becomes ethanol. So it breaks the double bond.
Here it is not going to become ethanol because chlorine is there. If everything is
Ah.
HHHH, then it will become ethanol. But here if polymerization is going to take place, then what's going to happen? Then over here, okay, this double bond will break.
Hmm.
Okay, on the other sides, this will get repeated. This is going to become, this is vinyl chloride.
Polychloroethane.
This is going to become polyvinyl chloride.
Or we can say
PVC.
polychloroethane. Ethene.
No, you just call it. The common name is commonly used name is PVC, polyvinyl chloride, and I've given you all the uses of those pipes and all those pictures. Also, I've given you
Hmm.
uses of PVC. So you finished all of the things that you had sent me. Anything else that you want to ask?
Yes, sir. I've written question. Yes.
Concentrated NaCl electrolysis,
And concentrated
concentrated aqueous NaCl electrolysis. There is no difference. Because concentrated, when you say NaCl can be dissolved only in water. It's the meaning of that is it is an aqueous solution.
Okay.
There is no difference.
And sir, in fractional distillation, like there are
Mm.
three liquids with boiling point 180, 170, and 210. So if
Mm.
we want to remove the last solution with 210, so then we have to first remove the 171, then 180, then 210, or we can directly remove the 210.
No, no, that's not possible. Because you see, when the mixture is there from lower temperature, it will go to higher temperature. So first, all 170 degrees Celsius liquid will boil off. then all 180 degrees Celsius liquid will boil off, and then finally what will remain inside that is going to be 210 degrees Celsius ka liquid. That liquid is going to remain finally.
So we can't heat it till 210 in the start only?
No, that's not possible.
Okay. And what do those glass beads do in that
Glass
column?
beads, they will just increase the surface area so that the separation of the liquid which is there, that becomes easier. The particles which are there, they can be separated easily. That's what the glass beads are doing in between in the fractional distillation process.
Okay. Sir, is it in carbonates that all group 1 carbonates are soluble?
Span. SPAN. This is the basic thing. The keyword is there. Sodium, potassium, ammonium. Everything is soluble. Whatever you put behind that, everything is soluble. Sodium dash dash dash. Whatever it is, it's soluble always. Potassium, ammonium, everything is soluble.
Lithium carbonate is soluble.
Whatever. Lithium is group 1, so it is soluble.
Okay.
Because you have to consider group 1 also when you are telling sodium, potassium. So lithium, so group 1, whatever is there behind whatever you put, everything is soluble. Same way for nitrate. Whatever you put in front of it, you don't have to think, it is soluble.
Okay. Sir, that we had done this, like few covalent bonds are strong. Like how are they strong? Few covalent bonds.
If they are having macromolecular structure, say like diamond, it's having a tetrahedral structure and it's getting repeated. The process gets repeated. So here this type of a covalent structure which is having macromolecular structure is very strong. Diamond is one of the hardest known substances.
Okay.
It's having highest melting point about 4000 degrees Celsius.
And why is nitrogen gas considered like to be nitrogen gas? It is also considered to be strong, right?
The bonds in nitrogen molecule, yesterday night I had sent you that picture, intermolecular forces. If this is one nitrogen molecule and there is another nitrogen molecule, then the forces of attraction between these molecules is less. So intermolecular forces of attraction are less.
Okay.
So that's why it's this melting point, boiling point is very low, because the forces of attraction are less. But if nitrogen has to react with somebody, like nitrogen plus hydrogen, N2 plus H2, then the bond between two nitrogen atoms, this is very strong. So I require large amount of energy to separate out these both N. This is not intermolecular force. It is the force of attraction between two atoms in a same molecule. Intermolecular force is between neighboring molecules.
Okay.
And this is the force of attraction between two atoms in the same molecule. It's called intramolecular force of attraction, but that's not important. At present, you have done only intermolecular forces, that is between the neighboring molecules. But if you want to react this nitrogen with hydrogen, then these both will have to be separated. These bonds are very strong. That's why it's very less reactive. You need very large amount of energy to separate out this NN, then only it will combine obviously with hydrogen to form ammonia.
So that is why nitrogen is known
Less
as
reactive.
unreactive.
Yes.
Okay.
Because there is a triple bond in it. So I need to separate this nitrogen, which requires very large amount of energy.
Okay. So what is lagging?
Lagging is whatever we are providing, that is in physics usually, to stop heat loss.
So to prevent heat loss, it is.
Yeah, this is a metal pipe through which the liquid is flowing. Then we provide something like cotton or something so that heat loss is prevented. That generally comes in physics.
Okay, I'll just check if I have something on.
Okay.
So what is the principle of Le Chatelier's?
That's Le Chatelier's process. Okay, that is what we have done in manufacture of ammonia. It's applied all to reversible reactions. If the reaction is exothermic, then low temperature will favor the forward reaction. And if the reaction is proceeding with say decrease in volume, high pressure will favor the forward reaction. All these statements that we have done.
So if I want to write the definition, if they ask
They
in,
will. No, nobody is going to ask you such definitions. It will be just direct application questions will be there. That this is the reaction. What will happen if you are using low temperature, low pressure, and so on.
okay. In dissociation reaction, it's compulsory that hydronium ion will form.
No, not necessary. Suppose if it is molten NaCl, there is no water over here. Where there will be no hydronium ion.
So it will be Na plus Cl minus.
This reaction, and whenever you are writing dissociation reaction, show it with a reversible arrow.
On the left side, you have to not put the ions, no?
Where?
On this left side. Ions on that side also have to put.
See, basically, this is an ionic compound, no? So already it is present in the form of Na plus and Cl minus because the electron is already transferred. You can write this as NaCl giving you this. This way also it's not wrong. This is also correct. This way also you can write. Generally we write it like this only, but this is also this is actually more correct because it's already in the electron is already transferred from Na to Cl. But in 10th standard level it's okay if even if you write this.
Sir, like in the solubility chart, it is written that calcium sulfate sparingly soluble.
Sparingly soluble.
So then it is soluble or insoluble?
It is very little. It's less than 0.1%. That's what is sparingly means. Very, very little, very, very less.
So I'll consider it insoluble.
That is taken as insoluble only. Because you can see the precipitate of calcium sulfate.
But in this, in the hydroxide thing, here we are considering calcium hydroxide and magnesium hydroxide as soluble.
No, that is see some amount of percentage is a bit more compared to calcium sulfate. So that's why that is what calcium hydroxide. What is calcium hydroxide solution? It's lime water. And that way, this we are using to test carbon dioxide. So when you pass carbon dioxide through it, it will form calcium carbonate, which is lime water milky.
And that will form a precipitate, calcium carbonate.
That is precipitate, CaCO3 and H2O. This is that because of this only it shows milky color. It's white in color.
Can you tell me the names of like CaO, that name of it?
CaO is quicklime. CaCO3 is limestone, marble, okay, whatever the other common names are. CaOH twice. If it is a paste, it's called slaked lime. If it is a solution, it is lime water. These are all the names.
So when we bubble in lime water, that time we get limestone.
Don't say we get limestone. Limestone contains calcium carbonate. That's a solid. It's occurring in nature in the
Okay.
solid state. It's very hard. And when you are passing carbon dioxide through lime water, which is the solution of this, then you are getting that powdered form. Because of that, it shows milky color.
Okay.
Calcium oxide water is added to it. This is giving you paste of calcium hydroxide. This is slaked lime.
Okay.
Here the reaction is so exothermic that this water starts boiling. Okay, and this slaked lime, where it is used for whitewashing of walls because it's cheap.
Painting.
Painting of walls, outside walls. It's very this lime is very cheap. Slaked lime is very cheap. That's why it is used.
Oh. And for the paste
This is paste, slaked lime.
and lime water.
Lime water, I have shown you this. This is the only reaction where lime water turns milky. You don't
So
have
the
to know when excess carbon dioxide is passed. That is not there in your syllabus. Here lime
chemical
water
name.
turns milky.
Hmm.
This is there.
Hmm.
That's all. What else do you need?
Chemical name for paste and the lime water is same.
Chemical name will be calcium hydroxide only.
Okay.
Here it is in the form of solution. There is no excess of it. Here excess is there. Insoluble part is also there.
Hmm.
That's why it is paste. If there is anything else, you can again call me. Cryolite, no?
Hmm.
Basically it is 3NaF and AlF3. This is cryolite. Why it is added in electrolysis of aluminium? It increases, first thing is that it reduces the melting point of Al2O3
Hmm.
from 2000 degrees Celsius. If this mixture is added, then the melting point is reduced to 1000 degrees Celsius.
Okay.
That is the advantage of adding cryolite, and apart from it, it also improves electrical conductivity, because this is finally going to form ions Na plus and F minus, and obviously this will be Al3 plus and F minus. These are the dissociation reactions for cryolite.
Okay.
Most
So the,
important advantages is the mixture. When you are adding cryolite, okay, it's going to reduce the melting point of the mixture from 2000 to 1000 degrees Celsius. So it's easier to carry out electrolysis at 1000 degrees Celsius rather than 2000 degrees Celsius.
we can't put cryolite in any other reaction.
You can, but here what is important is we are doing extraction of aluminium. That is more important.
Okay.
First four compounds, methane, ethane, propane, butane, all four of them will be gases at room temperature.
In alkene part also.
In alkene part also. All these will be gases.
Okay.
So this is how we are going to separate NaCl and NH4Cl.
Hmm.
This will sublime, turn into gaseous, cold glass surface, it will stick, ammonium chloride will get stuck over here, sodium chloride will remain behind.
Okay. Present, and it
Hmm.
is aqueous. So
Hmm.
oxygen will produce.
For electrolysis, right?
Yeah.
It depends upon concentration. For example, we have done so many times electrolysis of brine.
Hmm.
If it is concentrated, then this will give you Cl2 gas. If it is dilute, then it's going to give you oxygen gas. This will be at anode, which is the positive electrode.
And the won't be asked for that oxygen ka thing.
That OH minus ions giving you balancing can be asked. When they've asked balancing, they've given all the reactants and products, and balancing was asked. This can be asked.
So on that OH side, there will be no thing, or OH side.
This is given to you. You have to balance this equation.
How will you balance this one?
If this over here is an odd number, so I'll multiply this by 2. This makes 4 hydrogen. 4 over here, 4 electrons. This is balanced.
Okay.
That was about diffusion. Then is all apparatus properly you should name when you are writing the answer. Use proper scientific terms for every apparatus.
Dissolving is also considered as one scientific.
Diffusion, yes, obviously. It is. Always look into the periodic table for help whenever you need. Metallurgy ka O's which are there. Then there is a formation of all covalent compounds, that video that I had sent. Okay, how just memorize how each one of these substances are going to be formed, how the bonds are formed between them. These all we have done several times. Silicon 4 oxide, diamond, graphite. Why it's a good conductor of electricity. Writing ionic equations, you have to be for ionic equation you will have to write all state symbols. Mole mein you write proper units. You've done all of these several times.
What is the Avogadro's constant?
Avogadro's constant is that number of particles that are present in 1 mole of a substance. That is Avogadro's constant. It is always 6 into 10 raised to 23 particles. It can be atoms, ions, molecules, whatever. So 6 and then you put 23 zeros. 6 into 23 particles. This is called as Avogadro's constant. It is the number of atoms present, or number of molecules present, or number of particles present in 1 mole of a substance.
Okay.
You've done all electrolysis reactions, exothermic, endothermic, that energy profile diagram or energy graphs also we have done. Speed of reaction, equilibrium, we have discussed. Dehydrated salt and anhydrous salt, we have done. Color changes, and before, in between that gap which you get, color changes always you do that, all color changes, okay, during examination.
One is cobalt chloride, right? And one is calcium chloride.
Copper sulfate for testing water.
Copper sulfate.
Anhydrous copper sulfate, which is white, which turns blue on adding water. Okay, cobalt chloride is blue when it is anhydrous, when no water is there. When you add water, is going to turn pink. That is hydrated cobalt 2 chloride, which contains water of crystallization. This is for copper sulfate.
Copper sulfate.
Anhydrous, no water is there, it will be white powder. You add water to it, okay, it becomes blue in color. Of course, the reaction, you can reverse this reaction. If you heat again this copper sulfate, which contains water of crystallization, again it will turn into white powder. Same thing applies even to cobalt chloride.
Here it is 6H2O, there it is 5.
You don't have to learn that. You don't have to know that. In the break that you get, just go through the structures of macromolecules of organic compounds. nylon, terylene, and so on.
Okay. Which
Correct.
one is acid from?
This obviously is a basic substance, and this is acidic substance. So this is acid-base type of reaction. Calcium oxide is added in order to remove sand, SiO2. Okay, this blast furnace reaction. This gives you calcium silicate, which is slag.
Okay. Calcium oxide is a metal oxide. That is what is known as basic, right? It's a basic.
Yes, yes. Because it is a metal oxide, therefore it is a base.
Sir, after that, when we do crystallization, we have to get that filtrate.
Hmm.
So in the filtrate, we have to heat it and then you have to add more solution, right? Because
More solution.
like increasing the temperature increases solubility.
If you increase the temperature, solubility is increased. So you are not adding anything to it once the filter rate is obtained. You just keep on boiling off water. At one point, the crystals will start forming and then allow it to cool for a long period of time. That is going to give you pure crystals.
And if my crystals are forming as a filtrate, then what should I do?
Filtrate is liquid part.
Sorry, residue.
So you
Residue.
leave it. You leave it like that only in that case.
So,
Water bath will be used when you want to heat of a liquid like ethanol, which is a flammable liquid which can catch fire. If you are having ethanol, okay, in a test tube, for example, your ethanol is there.
hmm,
If we are supposed to heat this in order to carry out some reaction, for
okay.
example, if you want to carry out esterification reaction, okay, we will not directly put this on flame because ethanol is flammable, it can catch fire. So here water bath will be used.
We use water bath for more purposes, right? This is one. For one more thing we use.
There are several purposes for which water bath can be used. This is one of the purpose for which water bath can be used. Basically, the purpose of using water bath is anything that can catch fire that directly should not come in contact with the flame. That is the purpose of water bath. This is water bath. So water bath का ये purpose है. This is the purpose of water bath. Your water will be there. Here the flame will be there, which is going to heat up this water, and then because of higher temperature, then that is going to heat off whatever the contents are there in the test tube. In this case, it's ethanol.
Okay. So when like it's the question is saying this substance is being heated, so oxygen should be there or
Heated
no?
means you are just increasing the temperature. When you say burn,
Hmm.
at that time oxygen is also combining with it.
Okay.
Burning means you are reacting with oxygen. Heated means you are increasing the temperature. No, nothing to do with oxygen. Heated in air, if you say, yes, oxygen also is reacting with it.
Hmm. Sir, can you tell me like one more method of obtaining hydrogen? One is cracking of alkanes.
Electrolysis of water will give you hydrogen plus oxygen.
The common thing, yeah, that is, but we use it very rarely.
Another way is by water gas. Okay, steam is passed over coke, that is carbon. Carbon is coke plus H2O. This C will go with oil, with carbon monoxide, and then this part is going to become H2. Sorry, this is going to become hydrogen. This is how we. This is another method of obtaining hydrogen from water gas. That is steam is passed over carbon. You don't have to know the temperature, but this
But
is the
then
reaction.
this will
Reaction you
be
should know.
expensive. 100 degrees Celsius. In that organic chemistry, there was one reaction
Of what?
of obtaining hydrogen.
So this reaction can be used. Other one is cracking.
Okay. This polyethylene, polypropylene, polychloroethane, tetrafluoroethane, and phenolphthalein. I need to know the exam uses.
Phenolphthalein is used as indicator. You don't have to know the specific uses of each one of the polymers. PVC and such examples, specific examples that I have given you, that you have to know the important uses.
Methane.
Correct. CNG is containing 90% methane. LPG, liquefied petroleum gas, that is containing propane and butane. This part is important.
Okay. So there is batches.
Butanol is a biofuel. So wherever that particular alcohol will be used, that will find its use.